different packages to talk about. So generally the idea is like plotting in Python. And I guess like the motivation is that like normally we do a lot of stuff in R, obviously. And I guess I run into situations where like I'm doing some spatial analysis or something where I'm working with and data objects, and maybe I have some data in like a pandas data frame related to the spatial analysis I'm doing. And you have a few different options at that point if you're trying to do some visualizations. So either I guess the easiest option if you're only familiar with R is maybe just export the data frame and then have an R script and then do your plotting there. But often it's more convenient to be able to do it in the same Python script where you're doing your work. So if you do choose to do it in Python, then I think you have a couple options. So either you use plotting functions that people tend to use in Python. So that's sort of what I'll be starting with today. There's sort of two different I guess the main plotting options people do in Python are like, you can either use matplotlib directly, or you can use this Seaborn package. Seaborn is sort of built, it's a sort of a higher level library based on top of matplotlib that's focused more on just like constructing the plots themselves, and rather than constructing sort of individual components like the axes, there's more detail in matplotlib. So that's one side. And then the other side is that there's this package called plotnine, which I'll also talk about, which is basically ggplot in Python. And that's my preferred way to do things. But I think just to be fair to sort of like introducing both sides, I do want to show how people sort of tend to do things when they're in Python. So we'll start with Seaborn. So yeah, like I said, it's if you're familiar with matplotlib at all, it's more higher level. And yeah, let's get started with this. So let's go through this introduction tutorial here. So for now, I'll sort of go through this vignette, and then we'll actually run some code ourselves. But to start off, everyone imports the Seaborn package as SNS. That's just what everybody does. It's a very strong convention. So when you're importing it, I recommend importing it that way. And so they load this like tips data set just to give you an example of like how to plot. And actually I'm actually going to jump over to this tab here. Before we really show individual plotting functions, there was this visualization here that it can be sort of confusing coming from R, how things are organized in Seaborn or matplotlib or whatever. So sort of to understand the API, a lot of the plotting functions are categorized into sort of three different categories here. So this visualization here sort of shows you can either use the rel plot function. So these are for relational plots. So relational plots are like you're trying to show the relationship between two variables, for example. So the common things, probably the most common is a scatter plot when you have like X versus Y, just individual points. A line plot is similar, but you're showing sort of a trend as it progresses, usually through the X axis. So in Seaborn, you can actually call the rel plot function by itself, or you can call the more specific or scatter plot line. So it's a little confusing that there's like more than one option here, but this is sort of to understand like your options when you're working with the API. So similarly, if you want there's plots for distributions. I think the most common would be a histogram. So that's like the histplot function. So you can call displot with kind equals hist, or you can do histplot itself. So we will go through some of these examples with actual code, but just to give an overview of like how that works. And then there's other types of like this kernel density estimate. So in ggplot, that's sort of like a geom density. It's a density plot it's like a histogram, a smooth histogram. And then these ones actually I'm not familiar with, but they are also based on like the distribution of a single variable. And then you have, similarly, you can call cat plot for categorical plots, or you can call the individual ones. So like box plot is probably the most used version here, or a violin plot. Bar plots are also included in here. But yeah, so that's like the idea behind maybe the API and like what functions you can call. So I guess going back to this tutorial, they call the rel plot function. So if you look below, it's actually a scatter plot, right? So the way you would achieve this is like, actually, I'll show this in a bit, but I'll go through the rest of these parameters first and then go into a little bit more detail. So it's somewhat similar to ggplot in that you like give the data. It's just like a pandas data frame or like a data frame in R. Here is sort of like listing aesthetics. It would be the equivalent in ggplot. So X would be the name of the variable, in the x-axis, of course, not surprisingly, y for the y-axis. And then some of these arguments or these parameters sort of translate in different ways to ggplot. So this call is like similar to like facet wrap in ggplot. So that's where you have two columns based on the variable, the two different categorical variables in this time column in your data frame. Then hue would be like color in ggplot. And so you're coloring the points based on, this is like, I guess there's like the smoker variable in this data set. There's also style, which would translate to shape, I think, in ggplot for shape specifically for points, for geom point. And then size is the same thing as size in ggplot. So you can specify a bunch of different aesthetics for these plots, and then you can also facet. And most of these Seaborn plots are like, you can supply these same parameters and they have sort of the same logic. And so there's one thing I do want to show just real quick. So I'm going to come over to a session over here on the cluster. So I'm going to just open up a terminal. There's a bunch of ways you could do Python. I guess the most common way people normally, I guess, would be using like a Jupyter notebook for Python analysis. So I like to do Python sort of similar how I do R in the cluster. So that would be like having just a Python script with a terminal open and doing most of things by actually submitting jobs to the cluster. But today we'll be doing things interactively with just the script in the terminal. So yeah, I guess it's still worth mentioning, like Jupyter notebooks are what most people would use for what I'm doing today. But so anyways, I'm going to just load a module that I know I made a module for Visium HD work, which has some Python functions. I know it has the Seaborn and plotnine. So I'm going to load that and then open up a Python terminal. And so let's copy some of this code from the tutorial here. I'm going to import my libraries. I'm also not shown in the tutorial is importing matplotlib directly, pyplot specifically. And so also this will be important later when we talk about plotnine. This is just saying like import all functions from plotnine package. And this makes it more like ggplot in Python, or in R. So let's do this. Let's set the default theme here. We'll load data set and let's take a look at this data set real quick, since we didn't really do that. So yeah, a bunch of variables here. Basically like you have like different restaurant bills and then how much tip was given, and then data about sort of like, I don't know, what time of day it was and stuff like that. And so I do want to show like how I would do this. And since we're not in a Jupyter notebook and we're not actually just printing the plot directly, this code is not going to do anything. It's going to return this facet grid object. But that's why I import matplotlib. So if we were running this as a job, submitting it as a shell, like submitting the shell script as a job to Slurm and not doing anything interactively, then I would use like the matplotlib. I think it's save fig. So let's just call it like relplot1. And normally we like to do PDFs, right? So this is something, I don't know, this is something I personally don't like about, I find it very confusing about Python plotting, and especially matplotlib, is that it sort of just like creates this figure in the ether. Like it's just sort of out there. And then this save fig function has just memory that you plotted something rather than plotting an actual object. I don't know. I've always found that confusing, but so we can save that to a PDF, and then that's what we would do if we were submitting it as a job. And then that figure sort of persists, and future plots will have that figure in it. So like I tend to just do this sort of thing where we're basically closing all figures that are open. And then that just keeps things individual, so that if we do a series of plots, it's not plotting like multiple pages of previous plots and stuff, if that makes sense. Also found that confusing. But yeah, let's just show, I believe, so like I was saying, relplot is like the generic form of a relationship plot. In this case, we're actually doing a scatter plot, right? So I believe if we do kind equals scatter, that's sort of what's the default here that's implicitly being used here. So I think that this should do the exact same thing, I believe, and it should accept it. So yeah, that's sort of how you translate from the generic function to the more specific. So you could do relplot kind equals scatter, or you could actually do scatter plot. this should be the same thing. And then AI is suggesting I remove this thing, which is correct. So I didn't close the figure, right? Always remember to do that. And so this should be the same exact thing. Let's see. What is it complaining about? That's actually strange. So it's saying that I can't facet the scatter plot. Interesting. So yeah, my impression was that I've worked with Seaborn a little bit, but not super. I'm still learning about it. But I was suspecting that you should be able to use anything, all these parameters the same way if you use the scatter plot function versus doing rel plot kind equals scatter. So not sure why this is happening here. Let's see if I can remove this and try this again. And so it does let you do, I'm not sure what that is. That really should be supported. And it's very confusing that it's not. So anyways, that's our first example. We can continue through this tutorial to show different types of plots here. So they have a few notes about like how plotting differs if you're using Jupyter Notebook, like I sort of mentioned. Normally you would just use it just shows the figure in your notebook, or you can explicitly call the show function. Let's see. So this is the same stuff. So this is an example of a more complicated plot down here. So again, we're using like the rel plot because it's a relational plot between two different variables, also faceted by this align variable. And so they introduce a couple new different things here. So we still have the XY, hue, and size like we had before. Actually, I think we had style as well, but all of this is mostly the same, except they're also specifying some additional arguments saying that like basically don't share the have the same x scale for both of the facets. But other than that, this is like the only difference is this is a line plot, right? So we can do kind equals line instead of kind equals scatter from before. So yeah, I'll copy this over to have it for later, but I think you can sort of see we already ran it. So I mean, or we didn't run it, but it's kind of there. So I won't run this right now. I'll keep track of this because at the end, I'm going to sort of try to do the equivalent in plotnine. So I mentioned that package as well, but that's sort of why I'm copying it over here. So if we go through here, I guess this is pretty similar, right? I don't think we're doing anything special in this plot that's new from what we've done before. I guess the new thing here is another type of plot is like this LM plot. So I guess this would be like using geom point plus geom smooth in the ggplot. So it's sort of like a built-in version of like both a scatter plot and a regression line through the points. So yeah, I guess we'll keep going through here. Yeah, there's also, like I mentioned, there's like different ways to represent distributions. And so the generic plotting function would be displot, like I said. And so this is sort of a little bit weird because we'll do this one interactively to show how this works. So yeah, we see like you only specify x variable, right? Because it's the distribution of the x values. So there's no y here. Again, we're faceting by a variable here. I guess something that's weird here is that instead of doing the kernel density estimate plot itself, we're doing like a KDE argument here. So that has on the smooth version on top. So it's sort of like two plots in one. So let's copy this and let's do a little bit with this. So we have the tips data here. So this should run. And so we get the same thing that they get in this tutorial. So I think if you wanted to just do, let me make sure I'm understanding this correctly, because if we take out this KDE argument and we just do kind equals hist, I think, let's see, this should be just histogram. Yep, so there we go. So that kind equals hist is the default, right? So we're implicitly calling this whenever we do a dist plot. It's just doing a histogram by default. Or we can do this smooth kernel density estimate by doing kind equals KDE. And so yeah, so they did the version with both, which is why they had that special argument KDE was true. And yeah, any of the other types are supported as well. I think there was like actually I'll just show in here because I think they show this cumulative Okay, cumulative distribution function is the kind here. And then I think this rug is what's affecting this bottom part of these plots. But so yeah, lots of different options for these distribution plots. I guess we'll jump further down. I know I'm kind of rushing through this, so if anyone has something that they want me to try or any questions or anything, feel free to interrupt. But otherwise, I'll probably just jump into the categorical section here. So here's data this is a pretty common plot for us to use, right? So we're using the generic cat plot for categorical plot, kind equals swarm here. So I guess this would be, there is a GG swarm. I'm trying to remember if that's similar to what this is here, but this is more of like showing the points when you're doing a box plot or something in R, but I'm not sure exactly how you would do the equivalent. Anyways, you could do kind equals swarm, or let's actually try a few different options here. So this is what they do. So we'll just first replicate what they're doing here. And yeah, here we go. So that's correct. So it should be kind equals box for a box plot. Let me just make sure. Yeah. And then we do get the outlier points by default, just like we do in R. So if anything else we can modify here to, so box plot, I believe violin plots are just violin here. Yeah, I guess one thing I'm still unclear about, this is something I haven't tried yet, is if you can do multiple, like a box plot and a violin plot on top of each other. Because I think if you do, that would be something I still have to learn. I guess we're still doing the introduction here, so maybe not something we tried today, but a few different things that are like, I know how to do them in R, but not Seaborn yet. But so they also do a violin plot. We've tried the box plot version. There's also, oh yeah, kind equals bar would be the other option, right? A bar plot showing the, so,
Standard.
sorry?
I think that is showing the standard error.
Yeah.
The bar, the small bar.
Yeah, we do have a standard error bar here. So it is producing some statistics as well as.
I think that you can like make the overlaps in the plots that you say. I mean, more complex plots, just adding properties or something like that. There's a while that I have not tried to see that.
Yeah, I'm not sure. Yeah, so bar plots, they also have, I guess we can go through just to give an introduction about like other types of more complicated plots without going into too much detail. They have this join plot function, right? So this is like a scatter. We have a couple different things. We have a scatter plot, and then we have basically I guess this would be like a kernel density estimate plot for each variable across both the X and Y variables, if that makes sense. So like we have the distribution of these, like these chin strap points, the orange points here are like shown on the right here. Same for the other points. So we have a combination of, yeah, like a distribution plot and relational plot. They also have, this is cool, right? The pair plot is just like GG pairs, almost like GG pairs. GG pairs actually has more information, right? Because the bottom, the upper and lower diagonals have different information with GG pairs, but actually, never mind. I didn't even notice that these were different. So not quite sure what difference is between, like, for example, this plot and this one. Yeah, I'm not sure actually, but it is. So anyway, I guess to describe what this plot actually is doing is like we have.
Really is in the x-axis some description about it. You can just scroll here, there. I don't know.
Yeah.
Yeah, but sure.
Yeah, but we have pairs of these attributes that were like, this plot here would be like comparing the build length against the build depth, right? This is the penguins data set, and then coloring it by the species. And then we have a bunch of different penguins as points. And then like the diagonals would be just the variables themselves. So like if we're looking at the distribution of bill length across all penguins and then colored by species, that would be like forming these diagonals. So yeah, just like GG pairs, I guess. Almost. This stuff, I don't think there's more in this tutorial. I guess we can take a brief look. I think it's not really introductory stuff, but I haven't taken too much of a look at this, but it looks like you can basically build more complex figures with individual calls to additional functions. Like, looks like yeah, I would have to probably look more about this to give a good explanation, but I think we can jump into plotnine now, unless people have more questions about Seaborn for now.
It seems like that in G is defined like the grid, no window. Yeah, and then it's, for example, in the second line, in the same grid G object, it's in the second object. Yes, that is a density plot, and then it's adding the other, and it's defined like let's say the position of the plots in the grid defined in the G object. I mean, it's like for example, what page word does. The defines a grid and then it's adding over the object different like objects, because all are over the G element, but it looks nice.
Yeah, it does.
I don't know how much informative it is, but yeah. Even it has the diagonal there, no, in the box.
Yeah.
I mean, it's defining in the code.
Yeah, it's
yes, it's here defining a diagonal. Yes, that is the histogram plot where the key, the E2 that you say, that is like the lines over the histogram. Yeah, it's a cool one. Like, yeah.
So yeah, definitely more customization and stuff you can do than I covered today. So I guess we'll just take a look at these plots just to show what you can produce. Okay, that was it. Yeah, I think we can jump into plotnine. So I guess this is sort of an opinion. I think like Seaborn and Matplotlib, they're not really organized. Like there's certain things you can't do. Like the thing I was doing earlier, you would think that a scatter plot would support faceting in the same way that you would facet a relationship plot when the kind equals scatter, right? It's like two almost identical things, but the parameters don't mean the same things. So I think like I guess I'm just a big fan of ggplot and just like the logical way things are structured within ggplot. And so I prefer to use plot whenever I'm in Python. I just use plotnine. I don't use Matplotlib or Seaborn, but that's just, I guess, preference. And so I guess we'll go to the main page for plotnine. It basically is just this thing. It basically just is ggplot in Python, essentially. So they've implemented, if we go to like the reference, they've manually implemented, all the geomes. You can go in and they have code implementing these the same way that they're implemented in R. They have all the stats. I don't usually do too much with statistical computations, but I mean, ggplot has this support, right? All the faceting and, pretty much anything else you can think of. Every time I've used plotnine, I've been satisfied with like what was possible. Like I've never ran into a situation where something wasn't possible in plotnine, but was in ggplot. So like it's pretty complete in my experience. And so yeah, it's just a package in Python, so you can install it with pip. And I guess going into sort of like how it's implemented, there's a couple of different ways you could do this. So just because the way Python works, typically when you're importing a package, you have to name the package and then also the function you're calling, unless you say you explicitly import functions. So in this case, they're saying from plotnine import ggplot. So we can call it ggplot instead of plotnine.ggplot in the code, and same for the other functions. I think the more common thing to do here is to just do from like what I did in my code, which is like from plotnine import everything. So that would give you, that way you can just name like geom point by itself without having to list out every single function that you're importing. But yeah, you basically so since Python is a little bit more picky with spacing and tabs and stuff and new lines and all that, you do have to encapsulate your code in parentheses like this, because within parentheses, there's a lot less restrictions on what you can pretty much space anything how you want. And so everything else is really the same. You just call a ggplot with your data set, you name the aesthetics or whatever, and then you name your like geom point in this case. You can do a lot more. Any code that works in R pretty much works here in my experience, like I said. So it's pretty straightforward to use. And it's, I guess like I said, I think I mentioned it briefly. These are like pandas data frames, right? So that's the equivalent of a data frame in R essentially. And so it's built around those. And so, okay, I didn't actually know that they provide a pipe operator. So that's something they try to make it sort of tidy like, I guess, where you can do, yeah. So I guess the plus one is just part of the GG package, but this pipe operator is like, take the data set, you do, this would be like exactly like a filter in dplyr, and then pipe the data frame to ggplot. So it's really trying to make it more like tidyverse, I guess. And so there's not much to say. If you're familiar with ggplot, honestly, the good thing is there's really not much to say about plotnine. It's just is sort of ggplot, and it works as you'd expect it to. And so we can sort of go back to these examples here. So I already imported everything. So if we have a scatter plot, let's just do an example of like making the same scatter plot with this tips data set. So I'm just gonna do it like this. Okay. Or AI is just gonna write the entire thing for me, I guess. I was gonna go through it. It's probably right too. Let's see. Actually, I'm just gonna run with this. So let's go through this. So tips is the data frame, right? We are using, it's very similar, right? X and Y are just written the same way. I guess one difference I didn't mention is that like we're not using the variables are in quotes, right? They're not doing the non-standard evaluation or whatever that tidyverse stuff usually does. But other than that, it's pretty much the same. Like I said, hue from Seaborn translates to color. Style in the context of geom point translates to shape. Size is just size. Since it's a scatter plot, we're using geom point, and then this AI is trying to be extra and add a title when the other one doesn't have one. And then this is not really the same thing. So I'm just going to do these just to do a minimal example here. And so, yeah, you just invoke it like this. And then it's sort of the same as like the Seaborn plot, where I tend to use the matplotlib functions for saving it. There is a GG save function. I've tried to use it, and it's confused me. So I just I just kind of used my normal method. So let's do this and show what it looks like as a PDF. And it shows like the default figure size. Although when it's a PDF, it's vectorized graphics, so it doesn't really matter. In terms of resolution, at least. So we get something that actually, let's compare how these look. So we had draw plot one should be this up-to-date scatter plot. And so very similar. We have ggplot. I mean, it's not ggplot, plotnine picks different shapes that are default, I guess, for the points, pick different default colors. But other than that, it's pretty much, I mean, this is exactly how a ggplot function plot would look if you plotted it from R. Although actually the colors look slightly different, but that's not super important, right? So yeah, I guess I could go through more of these examples, but it seems like, yeah, let's just do one more. And so similar thing, we use our parentheses, and then AI is just completing everything from as before. So if we're doing a line plot, that translates to geom line, right? The call here equals a line translates to, I don't know what it just did, to the facet wrap by a line. This facet thing, share x equals false, translated to scales equals free x. Then everything else sort of translates how it did before, right? Hue is color, style is shape, and so on. So that's not consistent. And so, yeah, I mean, not much to say here. If you're anything you can do in ggplot, you can do plotnine, very straightforward. And so we'll today run this out there. Dots is not defined because, okay, let's load this data set. I don't think I actually ran this code either. So let's do that. Not sure what that means. So raw plot 2 is this. This is the plot from earlier. Let's do our ggplot or plotnine equivalent. And oh, that looks kind of messy. Why is that? Draw plot to and interesting.
I think it's the thin of the lines.
Just the thickness?
Yes.
Yeah. It looks like something else is wrong here, actually, isn't it? It's pretty bizarre. Yeah, no, you might be right. Yeah, because this coherence, like this thickness here, is kind of crazy, right? Compared to this.
Yes.
Yeah,
Like,
you're right. So yeah, I guess there's going to be some default differences in the defaults for how ggplot versus Seaborn handles certain aesthetics. So I guess that would be one difference. Don't expect it to look like Seaborn if you're using plotnine, obviously. So you'd have to fine tune. You would have to do like a scale. What is it? Sorry, let me go back to the scale size manual or something. I don't know. That might take a little bit to tailor, but yeah, I guess the defaults might not always, look as you expect them to. But and then just quickly, I won't do these because I think we don't really need to go through all of them, but like this plot kind equals KDE would be ggplot, and then geom density would be like sort of the main thing here, and then all the other variables are sort of covered. Cat plot kind equals violin would be geom bin, and then and so on. So yeah, I think that's all I really had for today. I don't know if there's questions or comments. Plotnine is awesome. Big fan.
just could you remind me what was the motivation to go into Python to make some plots instead to keep in ggplot?
So I wouldn't go into Python unless you are. So I mean, I guess in my experience, I've been testing out different like tools developed for like spatial analysis where they're Python packages, and so I have to be in Python. And I start out with my data in Python, so I just like to plot it there. And yeah, if you're in R, definitely just use ggplot.
Okay, but you start working with Python, so
Yeah,
Yeah,
a bunch of tools are written for Python these days.
Right. And so how do you feel about, for example, this plotnine, I think is
Yeah.
the name.
Yep.
It's like trying to make efforts to bring the R users into Python in an easy way because it's wrapping all these functions.
Yeah.
The user is familiarized. Even when there are a lot of packages in Python that you can use to do the same.
Yeah.
So do you find useful that?
I really like plotnine. I strongly prefer it to any option in Python, to be honest.
Mhm.
I've never liked Python plotting, just as my personal opinion. I've
Yeah.
always found it extremely confusing and disorganized. And the structure ggplot has an entire book written about it, about the grammar, of graphics and like how there's a purpose behind every choice being made in the package. And it really shows, I think, in how like the code is. So for that reason, I really think plotnine is important in terms of like, normally I don't really like the idea behind trying to port things to other languages. I'm usually like, sometimes those efforts are like incomplete or trying to, I don't know. But I think in plotnine's case, it's great.
So let's say that, for example, in terms of visualization in Python, so let's say that likely has more defined standard to follow the same kind of instructions or to make plots. So, like as you say, in a structured way, and likely there are a lot of these Python visualization packages, but there is not like a super defined standard.
Yeah.
So you need to try to learn and to implement things
Exactly.
more frequently.
It doesn't feel like they came in with like well-defined organizational principles that like it's almost like, not to be too critical, but it's almost like they came through and they just started writing the packets before thinking about how to.
I
Right.
got it.
Yeah.
Technique. I think that you have messages in the chat.
I always miss those, so I do.
There's a one there.
Leo, you should put positive. We can take a look.
It's just about how ggplot turned 18 recently.
Oh my God.
So like there's a reason why like it's been around for 18 years and it's like quite used.
Yeah, that's true.
Python, do you get like also the ggplot objects themselves? Can you manipulate the ggplot objects before rendering them? Like we can do in R?
I'm not actually sure. I believe it returns like actually a matplotlib figure object, not like ggplot
Object, okay.
Yeah. So it's a little.
So for example, like the plotly, the ggplotly function from the plotly package in R, there's no equivalent to that with plotnine. So I don't know if you're familiar with that function from the plotly R package that takes as input a ggplot2 object and then makes it interactive. Like I was just wondering this because I know that there's a plotly Python package too. I mean library.
Yeah.
So I don't know if plotnine and plotly in Python are compatible the same way that ggplot2 and plotly are compatible in R.
Right, that's a good question. I'm not sure off the top of my head. I would have to check. Yeah, I'm not sure if they mentioned something about plotly and.
Like it would be maybe on the Python side of things, right? Or
Yeah, that's true.
or like if they mention anything here about do you get an object or not?
Create a new ggplot object. Yeah, I guess I'm actually not super clear on how to manipulate what's returned and stuff.
Because I think that's also like one of the great benefits of ggplot in R is that you get an object out. So you can always edit the object and stuff like that before rendering it, compared to base R, where like in base R you're like it's almost like you're an artist and you're painting on the canvas. And so you can't say like I take this painting and now like tweak it. Right? You have to remake the painting from scratch if you want to tweak it.
Yeah, I'm not sure if you can. I mean, we could also test like if you, I don't know.
To see the class.
If we do like, yeah, I don't know. And then I'm not really sure how to.
You type of the class of object that you get there.
Is it type? I forget.
Type of, I think. Python.
ggplot.
But it's a specific class. Plotnine ggplot.
Yeah.
Yeah.
I think you can sort of do similar things. Like, I mean, at least like this minimal example of modifying after you've already, and I think I made it bigger or something. So I guess I didn't really check what this thing was suggesting, but yeah, it looks at least like internally, you can do this, but I'm not sure about plotly integration.
Okay, cool. Well, thank you, Nick. Thank you.